Well, here we have a sine of 2 times, and then it's an inverse trig function again. Remember, an inverse trig function is always an angle. What does that highlighted part mean? Really means the tangent of some angle, we'll call it A, is equal to 5 over 12. Well, that's not one we're supposed to have memorized, so we'll go ahead and we'll draw ourselves a triangle. Remember, tangent inverse is defined in quadrants 1 and 4. When is tangent equal to a positive? That's only in quadrant 1. So we'll draw ourselves a triangle in quadrant 1. Come out from the origin, make a right angle to the x-axis. Opposite of over adjacent, so opposite is 5, adjacent is 12. Use your Pythagorean theorem, you get your hypotenuse to be 13. So it's really sine of 2 times. This whole highlighted thing is an angle. We're calling that angle angle A. So it's really sine of 2 times A. So we do really have a formula for a double angle sine, which is 2 sine of your A cosine of your A. So we'll go 2 sine of A, sine, go up to A. Sine is opposite of 5 over hypotenuse of 13. Cosine of A is adjacent of 12 over hypotenuse of 13. And then you can multiply that together in your head or on your calculator, and you get 120 over 169. So that's an angle what's highlighted. So it's just sine of 2 times an angle, or a double angle sine formula. If you don't know that angle right here, then you draw yourself a triangle to represent it. We're going to do the same thing here. Arc sine or arc cosine, cosine inverse, same thing. It represents an angle. So if you're just looking at what's highlighted right here, represents an angle. What does it mean? It means the cosine of some angle, we'll call it B. You could call it anything you wanted, equals x. Or you could say the cosine of B is equal to x over 1. It's nice to have that because that allows us to be able to go ahead and draw ourselves a triangle. Doesn't really make a difference whether you draw it in quadrants 1 or 2. I'm going to just draw it in quadrant 1. Come out from the origin, go up, make a right angle to the x-axis. Do you know cosine is adjacent of x over your hypotenuse of 1? Use your Pythagorean theorem to figure out your opposite side. If you do that, you would end up getting the square root of 1 minus x squared. You're now just looking for the tangent, and remember this whole highlighted thing's an angle, which we have drawn over here, and we call that angle B. So we're just looking for the tangent of B. So we go over here, go B. Tangent, remember, is opposite, which is our root stuff, over your adjacent. And so then we get our answer. Here we have cosine 2, and then remember, any inverse trig function's an angle. So that highlighted part's an angle. So it's really cosine of 2 times an angle. So that's why we're having our cosine double angle formula show up down here. But let's just look at that highlighted part to begin with. That highlighted part's an angle. It means the tangent of some angle we'll call A is x, or x over 1. So draw yourself a triangle. Remember, you come out from the origin, make a right angle to the x-axis. Tangent is opposite of x over adjacent of 1 because it's x over 1. Use your Pythagorean theorem to be able to get your hypotenuse. 1 squared plus x squared equals your hypotenuse squared. So you get the square root when you take the square root of 1 plus x squared. So, once again, we said it's cosine of 2 times an angle. So it's just cosine of 2 times your angle. your double angle formula for cosine. You really have three of them to use. It doesn't make a difference which one you use. I chose to use this one here for your double angle cosine formula. So you're going to go to, take the cosine of your angle. Cosine is adjacent over your hypotenuse. And then it says you got to square it. And then it says you got to subtract 1. So you have your fraction here. So you got to go to, square the top, square the bottom. When you square the bottom, it gets rid of the root. Square the top, you get 1. But remember, it's 2 times that, so you get a 2 on top. So now we have a fraction over a fraction minus a fraction. So you got to have a common denominator. So you get a 1 plus an x squared on the bottom for your common denominator. So you got to multiply the top by that. Then you could write it as 1 fraction all over your denominator. Be careful on top, though. You got to make sure you distribute this negative through to each one of these when you are simplifying. So you really get a 2 minus a 1. And then distribute that negative through to your x squared. You get a negative x squared. Okay, we want to solve it for x. Well, that means you got to get rid of the 6. So you could subtract 6 from both sides. You got to get rid of the negative 3. So you could divide both sides by negative 3. And then you got to go ahead and get rid of your cosine. To undo your cosine, oh, that's just your cosine inverse of both sides. Now we want to solve this for theta between negative pi over 2 and positive pi over 2. We have no greatest common factor, but we do have 4 terms, so we're going to factor by grouping. Look at the first 2. What could you pull out of the first 2? Well, you could pull out a 6 and a sine squared. What are you left when you pull out a 6 and a sine squared? Well, you're left with, before the plus sign, you're left with a sine. After the plus sign, you're left with a 3. Over here, what can you pull out of the stuff underlined in orange? Well, they're both negative. They both have a 5 that could go into them, so pull out a negative 5. What are you left with? A negative 5 times what gives you that? Just a sine. Negative 5 times what gives you a negative 15, and that's a positive 3. And this is equal to 0 here. So, since both parentheses that we have right here are the same, all you have to do is pull that parenthesis out, because that's like your common factor now. Pull out that sine plus 3. So it disappears. It leaves you here. That disappears with the 6 sine squared x minus your 5 equal to 0. 2 things multiply together to give you 0, so you set each one equal to 0. Solve each one of these for your sine. This one over here is easy because remember, your sine's only going from 1 to negative 1, so it will never make it to negative 3. Over here, solve it for sine squared, so you'd add a 5, divide by 6. So you get a sine squared equaling a 5 over 6. Then you want to go ahead and take your square root. Now that's not one you're supposed to have memorized off the top of your head. So you just go ahead and you type that into your calculator. So into your calculator you would type sine inverse a root 5, 6. Or, and that would give you the first one that we have here. To get the second one, you would do the same thing, but you'd have the negative in front. And in either case, you get your 2 answers. Remember, sine inverse is defined to be between negative pi over 2 and positive pi over 2, and that's what we were looking for our answers in between.